A stone guardian has been whispering a secret for thousands of years. The Great Sphinx of Giza is not merely a statue. It is a geological mystery etched by forces we struggle to explain. This video will give you a front-row seat to one of history's most intense academic battles, the debate over the Sphinx Water Erosion Hypothesis. We will examine a startling claim that this iconic monument is not 4,500 years old, but perhaps twice that age, a relic from a time when the Sahara was green. You will meet the scholars who dared to challenge established history and see the evidence that has divided experts for decades. How could the weather patterns on a single block of limestone threaten to rewrite our entire timeline of civilization? And if the mainstream story is wrong, what forgotten chapter of human achievement does the Sphinx represent? By the end, you will have the full picture to decide for yourself what truths are carved into that ancient stone. What does it mean when the ground we stand on holds a deeper story than the one we've been told? That official story paints a picture of supreme mastery, a civilization at its peak carving its legacy directly from the earth. The Sphinx is attributed to Pharaoh Khafre, the ruler believed to have built the second pyramid at Giza. Based on alignments with his pyramid complex and the style of nearby temples, Egyptologists have placed its creation around 2,500 years before the Common Era. This timeline is elegant and fits neatly into our understanding of ancient Egyptian history. It tells us the Sphinx is a 4,500-year-old symbol of royal authority, likely a depiction of Khafre himself as a divine guardian watching over the necropolis. Its purpose is woven into beliefs about the sun god, a colossal sentinel for a king's journey into the afterlife. This narrative is powerful, deeply researched, and forms the bedrock of mainstream Egyptology. Yet, if you look closely, you'll notice something fascinating. This dating isn't written in hieroglyphs on the Sphinx itself. There is no inscription that says, "Built by King Khafre." The attribution comes from context, from architectural links and scholarly deduction. It's a conclusion drawn from the world around the statue, not from the statue's own stone. And that is a crucial distinction because it means the timeline, while widely accepted, is an interpretation. It's a hypothesis built on cultural and archaeological evidence, waiting to be tested against another kind of evidence entirely, the kind written not by human hands but by wind, water, and time. This sets the stage perfectly for a clash of disciplines, where the tools of the geologist meet the records of the historian. What happens when the very stone of the monument begins to tell a different story than the one we've assembled from its surroundings? Here was the crack in the timeline, a detail seen by countless eyes but interpreted in a new way. In the 1970s, a researcher named John Anthony West brought a different kind of vision to the Sphinx. He was not an Egyptologist by training, but a scholar of ancient symbolism, deeply influenced by the unconventional ideas of a French philosopher named R.A. Schwaller de Lubic's. Where others saw a majestic statue, West saw a geological document. His critical observation was this: the weathering on the Sphinx body and the deep walls of its pit looked nothing like the sharp, sand-blasted surfaces you would expect from thousands of years of desert winds. That kind of erosion creates crisp edges and horizontal grooves, like stone carved by a relentless, grainy file. What West documented were deep, rounded channels, vertical runnels, and undulating, scalloped hollows that seemed to cascade down the limestone. To his eye, this pattern spoke of a different force entirely, the kind that leaves its signature not with an abrasive whisper, but with a liquid flow. He proposed these were the unmistakable marks of water erosion from heavy, persistent rainfall. This was a staggering suggestion. It meant the primary weathering on the Sphinx occurred not in the arid climate of the last 4,500 years, but in a distant epoch when the region experienced a much wetter climate. That single question, born from looking at stone with fresh eyes, did more than challenge a date. It proposed that the Sphinx's true age was written in the very language of the weather, a language that told of green Sahara and forgotten rains. The implications were seismic, threatening to detach the monument from the pharaohs we knew and place it in a far more ancient and mysterious context. A bold idea demands rigorous proof. To move his water erosion theory from observation into the realm of scientific debate, John Anthony West knew he needed a specialist, someone whose word carried weight in a field far removed from archaeology. He found that authority in Dr. Robert M. Schoch, a respected geologist from Boston University. In the early 1990s, Schoch brought the tools of his discipline to the sands of Giza, not to study art or inscriptions, but to read the stone itself. His analysis was meticulous, focusing on the very patterns West had identified, the deep vertical fissures and the strangely softened, undulating profiles of the limestone walls surrounding the Sphinx. What Schoch saw through the lens of geology was a textbook case. He concluded that these were not the effects of wind and sand, which typically create sharp, horizontal abrasions. Instead, he argued these were classic signatures of precipitation runoff, the kind of weathering caused by heavy, persistent rainfall over a very long period. This was a professional verdict that changed everything. For such significant water erosion to have occurred, the climate at Giza would have needed to be radically different, much wetter than it has been for the last several thousand years. Schoch pointed to a climatic window that closed with the end of the last ice age, a time when the Sahara was a verdant landscape. His geological testimony suggested the core structure of the Sphinx could date back to 7,000 years before the Common Era, or even earlier. With that single analysis, the conversation was transformed. What had been a speculative theory was now a serious academic challenge, backed by geological testimony. The Sphinx was no longer just an archaeological puzzle. It had become a geological witness, and its testimony threatened to separate the monument from the pharaohs of the Old Kingdom by thousands of years. If the stone itself was telling this older story, then who or what could have been responsible for its creation in that distant, rain-swept past? Geology gave the water erosion claim a powerful voice, but to test its truth, we must listen to another witness, the ancient climate itself. Dr. Schoch's entire hypothesis rests on a simple, undeniable fact. The stone could only have been weathered that way if the weather itself was radically different. So we must ask, what was the climate of Egypt like thousands of years before the pyramids? The answer lies deep within lakebed cores, fossilized pollen, and cave formations from across North Africa. This evidence paints a portrait of a world unrecognizable from the desert we see today. For several thousand years, ending roughly around 5,000 years ago, the Sahara was not a sea of sand. It was a green savanna crisscrossed by rivers and lakes teeming with life. This period, known to scientists as the Neolithic subpluvial, was a time of significant rainfall. It was an era when the landscape around Giza would have been capable of delivering the sustained, heavy downpours needed to carve those deep, vertical channels into limestone. This climatic window is the linchpin of the argument. If the Sphinx shows clear water erosion, and the last time such erosion was possible ended around 3,000 years before the Common Era, then the monument's exposure to the elements must predate that climatic shift. This logic pushes the Sphinx's origins back into a shadowy epoch, potentially 7,000 to 10,000 years ago. Let that time frame sink in for a moment. This isn't just a matter of adding a few centuries to a pharaoh's reign. This places the core sculpture in a period before dynastic Egypt, before the invention of hieroglyphic writing, and possibly before widespread agriculture even took root in the Nile Valley. The implication is staggering. It suggests a monument of staggering sophistication and scale was conceived and executed by a society or culture that, according to conventional history, should not have possessed the organization, the manpower, or the technical skill to execute such a project. The water on the stone becomes more than just a weathering pattern. It becomes a climate clock, ticking backwards into a forgotten chapter of human ambition. Who were these people, and what compelled them to carve a lion from the living rock in an age we have barely begun to understand? But a claim this revolutionary was never going to stand unopposed. The guardians of traditional Egyptology mounted a formidable and detailed defense of the established timeline, leading voices like Dr. Zahi Hawass and Dr. Lehner presented a powerful counterargument, rooted in decades of fieldwork and a deep understanding of the Giza Plateau. Their rebuttal did not dismiss the erosion patterns outright, but offered alternative explanations grounded in the harsh realities of the local environment. They argued that the distinctive weathering could be the result of several forces acting together over millennia. The relentless wind carrying abrasive sand could indeed create rounded features, especially when combined with a process called halite weathering. This occurs when salt crystals drawn from groundwater or morning dew form within the stone's pores. As these crystals expand, they slowly pry the limestone apart from the inside, creating a pitted, softened surface that can mimic water wear. Other possibilities included periodic flooding from the nearby Nile or even capillary action from a higher water table in the distant past, processes that do not require a radically different climate. More importantly, they anchored their defense in the undeniable archaeological context. The Sphinx is not an isolated monument. It is physically and ceremonially linked to the pyramid complex of Khafre. The alignment of its temple, the causeway leading from it, and the very orientation of its gaze all weave it into a single, coherent architectural plan from the 4th dynasty. To separate the Sphinx from this context, they argued, is to ignore the most direct evidence we have. It would be like finding a single, strangely weathered stone in a medieval castle and using it to argue the entire fortress was built by the Romans while disregarding the flags, the armor, and the documents found within its walls. The mainstream position framed the water erosion theory as a fascinating but ultimately flawed interpretation, one that misunderstood the complex dialogue between stone and environment in the Egyptian desert. The battle lines were now clearly drawn, with geology on one side and archaeology on the other, each claiming to hold the true key to the Sphinx's age. To understand this clash, we need to look closer, down at the very texture of the limestone. The debate transforms from a grand historical argument into a microscopic war of interpretation, fought over the shape of every pit and channel. Those who see water point to what they call the unmistakable signature of rain. They show us the deep, vertical runnels that carve down the Sphinx's body and the enclosure walls. These aren't random scratches, they argue. They follow the natural vertical joints in the bedrock, exactly where flowing water would seek the path of least resistance, gouging out these dramatic fissures over centuries of downpour. Then there are the rounded, undulating hollows, the kind that make the stone look like softened clay or Swiss cheese. This, they say, is the textbook result of precipitation beating directly on a surface, dissolving and washing away the softer components of the stone in a diffuse, all-over pattern. It's the difference between a sharp, sand-blasted edge and a smooth, water-worn pebble, but on a monumental scale. The opposition sees the same features and reads a completely different story. They point out that the limestone at Giza isn't uniform. It's like a layered cake, with bands of hard rock alternating with bands that are much softer and more fragile. Any weathering process, whether from wind, water, or even just daily temperature swings, will affect these softer layers more dramatically, creating recesses and holes. But their key alternative is a process called salt exfoliation. In the arid desert, moisture from the air or even from the ground itself can seep into the stone. As it evaporates, it leaves behind tiny salt crystals. These crystals grow, exerting immense pressure from inside the rock, slowly forcing thin flakes and layers to pop off. This process doesn't create sharp, wind-sanded edges. It creates pitted, cavernous, and rounded formations that can, to an untrained eye, look remarkably like water wear. It's a patient chemical peeling, not a hydraulic carving. So the central question becomes this: are we looking at the slow, dissolving work of ancient rain, or the persistent, crystalline pressure of a dry desert fighting itself? The answer isn't just academic, it's etched into every inch of the stone, waiting for us to learn how to read it correctly. This geological debate is further clouded by a very human story, the story of preservation. The Sphinx we see today is not a pristine artifact frozen in time. It is a patient that has undergone repeated surgeries across millennia. Its long history of restoration adds a profound complication to reading its weathered skin. The most famous early repair dates to the New Kingdom, over 1,000 years after its traditional construction. The dream stele, erected between its paws, tells how the young Prince Thutmose, resting in its shadow, was promised the throne if he cleared away the sand swallowing the statue. He did, and as Pharaoh Thutmose IV, he ordered the first major restoration, shoring up the crumbling body with stone blocks. This was not the last intervention. Centuries later, the Romans added their own layers of repair, and in modern times, extensive campaigns in the 20th century used countless tons of mortar and new limestone to stabilize the eroding figure. Each effort was a lifeline, saving the guardian from total collapse. But each layer of new stone, each patch of ancient mortar, also acts as a bandage over the original wound. It alters the surface, changes how water or wind might flow across it, and may even mask the very erosion patterns geologists seek to study. Critics of the older timeline pose a crucial question. When we look at a deeply weathered section, how can we be certain we are seeing primordial damage from ancient rainfall, and not the effects of a slow decay that accelerated after a forgotten repair from 2,000 years ago failed? A crack filled in the Roman era might have later reopened, creating a fissure that looks ancient but is actually relatively young. This history of loving intervention means the Sphinx's body is a palimpsest, a stone manuscript written, erased, and rewritten by both nature and human hands. Separating the original text from the later notes becomes a task of immense difficulty, casting a shadow of legitimate uncertainty over any single interpretation of its scars. The stone tells one story, but what secrets lie hidden beneath it? As the debate over surface erosion raged, researchers turned to technology that could see through the sand and into the very heart of the plateau. Ground-penetrating radar and seismic refraction surveys sent pulses of energy deep below the Sphinx, listening for echoes that might reveal its hidden architecture. The results were tantalizing. The data suggested anomalies, cavities, and what appeared to be tunnels or chambers beneath the massive pores and along the northern flank of the enclosure. For those who believe the Sphinx is far older, these findings were electrifying. They pointed to the possibility of hidden rooms, perhaps even a lost hall of records, a repository of knowledge from a forgotten civilization buried in the bedrock. It seemed like technological validation that there was more to this monument than met the eye, that its true purpose and age were literally buried. Yet, as with every piece of this puzzle, interpretation is everything. Mainstream geologists studying the same data urge profound caution. The limestone bedrock of the Giza Plateau is naturally fractured, they explain. It is a Swiss cheese of ancient fissures, dissolved pockets, and voids created by water action over millions of years, long before any human set foot there. What radar might flag as a man-made chamber could very easily be a natural geologic feature. The debate over these subsurface shadows perfectly mirrors the larger conflict. One side sees deliberate construction, hidden evidence of a deeper history. The other sees the ordinary, if complex, geology of a limestone formation. This technological layer adds a new dimension to the mystery, but it does not solve it. Instead, it deepens the intrigue, reminding us that the Sphinx is not just a statue on the sand. It is the visible peak of a vast subterranean geological formation, and any truth about its origins may be woven into that hidden foundation. The search for answers, it seems, must now look down as much as it looks up. Yet the stone guardian does not stand alone. Beside it lies another puzzle, a structure often overshadowed by its colossal neighbor, the Sphinx Temple. This temple is built from enormous limestone blocks, some weighing over 100 tons, and they tell a story that is deeply intertwined with the central debate. The connection is physical and undeniable. The core blocks of this temple were quarried directly from the trench surrounding the Sphinx. When the ancient builders carved the lion's body from the bedrock, they didn't discard the removed stone. They shaped it into the very walls of the adjacent sanctuary. This means the temple stones are geological siblings to the Sphinx itself, sharing the same origin and, crucially, the same exposure history. Proponents of the water erosion theory point to this temple with keen interest. They observe that its massive core blocks display the same distinctive weathering patterns, the same deep, vertical channels and rounded hollows. If the Sphinx's body was eroded by ancient rainfall, they argue, then these blocks, sitting exposed in the same enclosure, must have endured that same weather. They were carved from the same stone, placed in the same environment, and thus bear the same chronological signature. This observation creates a powerful domino effect. If the temple's core structure is as ancient as the proposed date for the Sphinx's initial carving, then we are no longer discussing just a single, weathered statue. We are looking at an entire, sophisticated architectural complex from a previously unrecognized epoch. The temple itself is a marvel of megalithic engineering, with its precisely fitted cyclopean blocks. To attribute this level of stoneworking mastery to a pre-dynastic culture would force a dramatic rewrite of our understanding of early technological development. It suggests a lost chapter where architectural ambition existed on a scale we've only ever associated with the pyramid builders, but thousands of years earlier. The temple, therefore, becomes more than a corroborating clue. It becomes a second witness, its stones echoing the same ancient testimony, challenging us to explain not one mystery but two. But this theory of an ancient monument faces a curious and visible challenge: the head itself. Look at the Sphinx from the side, and a striking detail emerges. The head is noticeably, almost awkwardly, small in proportion to the massive leonine body. This isn't just an artistic choice, it's a geometric puzzle. If the body is that of a lion, the head should be far larger to match its powerful shoulders. This odd disproportion has fueled one of the most fascinating speculations within the older Sphinx hypothesis. Could the head we see today be a later modification? Proponents like John Anthony West suggested a compelling scenario. Imagine an original monument carved thousands of years earlier depicting a full lion. Over millennia, the body and the head of this lion would have weathered equally, battered by those proposed ancient rains into a softened, rounded form. Then, centuries or even millennia later, a pharaonic ruler arrives. He sees this ancient, eroded guardian and recognizes its power, but its features are no longer distinct. So his sculptors set to work. They take that large, weathered lion's head and recarve it, cutting it down, reshaping the stone into the smaller, human visage of a pharaoh, complete with the traditional Nemes headdress. This would explain the size discrepancy perfectly. The body is the original, colossal lion form. The head is a dynastic reduction, a political rebranding etched onto a far older relic. The theory finds a potential clue in the weathering itself. Observers note that the head's limestone appears less deeply eroded than the body and the enclosure walls. Could this be because its surface is newer, having been exposed to the elements for a shorter period since its recarving? It's an elegant idea, solving two mysteries at once: the proportion problem and the possibility of an older core structure. It paints a picture of cultural appropriation on a monumental scale, a later civilization finding an ancient, enigmatic guardian and literally reshaping its face to claim its legacy. This single monument, if its older timeline is true, becomes a key that could unlock a door to a forgotten world. Accepting a sphinx carved 7,000 years before the Common Era does more than just change a date on a museum plaque. It forces us to rewrite the opening chapters of the human story. Think about what that time frame represents. This would place the Sphinx's creation thousands of years before the first cities of Mesopotamia, before the rise of the pharaohs, and even before the widespread adoption of agriculture in the Nile Valley as we understand it. According to conventional history, this was an age of small, scattered communities, of hunter-gatherers and early farmers just beginning to settle down. Yet here we would have a society with the vision to conceive a lion the size of a building, the engineering skill to execute it, the organizational power to marshal a workforce for years, and the astronomical knowledge to potentially align it with celestial bodies. This is not a minor adjustment. It suggests a previously unrecognized chapter, a sophisticated culture that mastered stone and scale in an era we have always labeled as primitive. The question then becomes inevitable and haunting. Who were they? What kind of world did they inhabit? And what monumental belief or knowledge drove them to leave such a permanent mark on the landscape? Their achievement stands in silent contradiction to the linear, progressive model of history we are taught, where civilization slowly evolves from simple to complex. The Sphinx, in this view, is not a beginning but an echo. It hints at a peak, a high culture that flourished and then vanished, leaving behind only this colossal, enigmatic sentinel as a clue to its existence. This idea naturally resonates with other enduring mysteries, from the submerged structures off the coast of Japan to the precise stonework of Puma Punku. It touches a deep human fascination with lost worlds and forgotten wisdom, with the possibility that our past is far deeper and more mysterious than our records show. The debate over watermarks on limestone, therefore, is about much more than geology. It is a debate about origins. It challenges us to consider whether civilization has a single cradle, or whether it flickered into brilliance in multiple places at different times, with some of those lights going dark long before others ever began to shine. The true age of the Sphinx is not just a scientific puzzle, it is a philosophical one, asking us what we are willing to believe about our own capacity in the distant past. But beneath the clash of evidence lies another, equally revealing conflict. The battle over the Sphinx is not just about geology versus archaeology. It is also a story about how knowledge itself is defended and challenged. Over the decades, a powerful narrative has emerged from those who champion the older timeline. They argue they are not merely debating a date, but confronting what they call an academic fortress. Their charge is serious, that mainstream Egyptology operates as a kind of intellectual guild, deeply protective of its established story and resistant to challenges from outside disciplines like geology. They point to personal experiences, stories of research permits being denied, of papers being rejected from traditional journals not on the basis of data, they say, but because the conclusions dared to upend a century of consensus. In this telling, the debate is framed as a classic struggle of the outsider against the institution, of a radical idea being silenced by the gatekeepers of history. It is a compelling human drama, one that paints the Sphinx not only as a stone mystery, but as a symbol of academic rebellion. the emotional core of this argument resonates far beyond the sands of Giza, touching a universal nerve about who gets to write our past and whose voice is considered valid. This meta-debate adds a layer of modern intrigue to the ancient stone, transforming a scientific disagreement into a parable about authority and open-mindedness. How we handle disruptive ideas, it suggests, can be just as important as the ideas themselves. Yet the stone itself holds other possible explanations. While the water erosion theory paints a vivid picture of ancient downpours, mainstream geologists point to a more patient, insidious force at work right here in the desert. Their leading counterargument is not about wind or sand alone, but about chemistry and crystals. It's called salt weathering or haloclasty, and it's a process as relentless as it is invisible. Here's how it works. In the arid environment of Giza, moisture still finds a way. It comes from the morning dew that settles on the cool stone, from the rare but occasional rain shower, and perhaps most importantly, from groundwater. The Nile is not far away, and water can travel upward through the porous limestone like a sponge, carrying dissolved salts from the earth. When this moisture reaches the surface of the Sphinx and evaporates under the hot sun, those salts are left behind. They don't just sit there, they recrystallize, and as these tiny crystals form and grow, they exert a tremendous prying pressure from within the stone's own pores. Imagine freezing water in a crack in a sidewalk. That expansion is what splits the pavement. Now picture that happening on a microscopic scale, millions of times over for thousands of years. The result is not a clean cut, but a slow, granular exfoliation. Thin flakes and layers of the limestone surface simply pop off, grain by grain. Over centuries, this process can sculpt the rock into those very same pitted hollows, rounded cavities, and cavernous features that others attribute to flowing water. It's a quiet, chemical crumbling that requires no lost epoch of rain, just the ordinary, dry climate of the last several millennia, working with the natural salts in the stone and the ever-present hint of moisture in the air. When combined with the abrasive, sandblasting effect of the wind, which can further smooth and round these salt-weakened surfaces, this mechanism presents a complete and elegant explanation. It suggests the Sphinx bears the scars of its long, patient battle with the desert itself, not with a climate that vanished long ago. Rain is not the only water that can carve stone. There is another, more violent possibility waiting in the wings of this debate. Some researchers who see the unmistakable hand of water in the Sphinx's scars propose a different aquatic culprit altogether, one of catastrophic scale. Instead of centuries of persistent rainfall, they look to the power of sudden, immense floods. Imagine not a steady downpour, but a wall of water. One compelling theory points to a hypothesized ancient mega-lake in the Sahara, a vast inland sea geologists call Lake Mega-Chad. During particularly wet climatic phases, this colossal lake could have overflowed its basin in a cataclysmic outburst, sending torrents hundreds of miles across the landscape. Another possibility points closer to home, to the Nile itself during its most extreme flood cycles in a wetter era. A Nile flood of truly biblical proportions, rising far higher than any recorded in dynastic times, could have surged over the Giza Plateau, engulfing the Sphinx enclosure in a raging, temporary sea. The force of such an event would be unimaginable, a hydraulic battering ram capable of scouring deep channels into limestone in a matter of days or weeks, not millennia. This flood theory offers a fascinating middle path in the chronological war. It accepts the water erosion evidence but proposes a mechanism that could compress the timeline dramatically. A single catastrophic event, or a short series of them, could inflict the damage we see. This potentially allows for significant water weathering to occur within a time frame that might still align, however uneasily, with the traditional dating of the monument. The Sphinx would still be old, but its most dramatic scars could be from a freak natural disaster within the known climatic history of the region, rather than proof of an entirely lost epoch. It transforms the narrative from one of patient, ancient climate into one of sudden, earth-shaping violence, a story where the guardian itself was shaped by a forgotten deluge. So how does the Sphinx's weathered skin compare to other ancient patients? To truly understand if its erosion is unique, we must place it side by side with other monuments from Egypt's deep past. This comparative analysis is like a detective examining multiple crime scenes, looking for a signature that matches. Take the Osirian at Abydos, a mysterious, subterranean structure often linked to the god Osiris. Its massive granite blocks are undeniably ancient, and they show wear, but the pattern is different. The erosion there appears more generalized, a product of groundwater and time, lacking the dramatic, vertical runoff channels so prominent on the Sphinx enclosure walls. Then consider the Valley Temple of Khafre, the very structure traditionally connected to the Sphinx's builder. Built from similar limestone and granite, it shows weathering, yet many observers note it doesn't display the same degree of deep, undulating hollows. For those who believe the Sphinx is far older, this contrast is telling. They argue that if all these structures were exposed to the same environmental forces over the same 4,500-year period, their weathering should look more similar. The fact that the Sphinx's erosion seems more pronounced and of a specific type, they suggest, points to it having stood exposed under a different, wetter sky for a longer stretch of time. It positions the Sphinx not as a peer to these other temples, but as a predecessor, bearing the marks of an earlier, forgotten climate. Skeptics, however, urge caution against this apples to oranges comparison. They point out that every site has its own microclimate and geological story. The stone at Abydos is different. Granite versus limestone reacts to moisture and salt in distinct ways. The exposure matters immensely. A structure buried in sand for centuries would weather far slower than one left fully exposed on a windy plateau. Even the angle of a wall can change how water runs off it or how salt crystals form. A direct side-by-side comparison, they argue, is fraught with variables. The Sphinx sits in a deep, man-made pit that acts like a bowl, potentially collecting moisture and fostering unique weathering processes that a freestanding temple wall would not experience. This counterpoint reminds us that geology is rarely simple. Two structures can be the same age yet look wildly different based on their immediate environment, the specific composition of their stone, and their history of burial or exposure. So the question remains, is the Sphinx a true outlier, a geological anomaly pointing to a lost age, or is it simply the most dramatic example of a common story, where local conditions conspired to etch its surface with unusual intensity? The answer depends entirely on which variables you believe are most important in the slow conversation between stone and sky. Beyond the scientific journals and academic conferences, this debate touches something far more tangible: the very identity and economy of a nation. The Great Sphinx is not just an ancient statue, it is a modern symbol, a cornerstone of Egypt's cultural heritage and a global icon that draws millions of visitors from every corner of the world. This reality adds a profound, practical weight to the question of its age. The official narrative, placing the Sphinx firmly within the age of the pharaohs, is meticulously woven into the fabric of national identity. It is the story presented in school textbooks, narrated on guided tours, and celebrated in museums worldwide. This timeline forms the backbone of a vast cultural and economic ecosystem. To fundamentally challenge that story is to risk unsettling a deeply held historical self-image and a meticulously constructed tourist experience. Imagine the ripple effects. Museum exhibits carefully curated over decades would need rewriting. Educational curricula would require revision. The entire narrative presented to visitors at the Giza Plateau, a story of pyramid builders and divine kings, would face a seismic shift. This potential for disruption creates an invisible layer of pressure within the debate. Theories that reinforce the established 4,500-year timeline naturally align with existing infrastructure and public understanding. They receive a platform in official channels, are featured in government-sponsored publications, and form the basis of the story told to tourists. In contrast, a hypothesis that proposes a forgotten civilization predating the pharaohs by millennia challenges not only history books, but also the smooth operation of a major global industry. This socio-economic dimension helps explain why the controversy surrounding the Sphinx is so uniquely heated. The stakes extend far beyond who is right in a geological argument. They touch upon national pride, international prestige, and significant economic interests. Funding for research, access to the site for new studies, and media coverage can all be influenced by this complex backdrop. It is a reminder that our understanding of the past is never shaped solely by evidence in the ground. It is also shaped by the stories we choose to tell about ourselves in the present, and by the very practical realities of sharing those stories with the world. When a monument becomes this central to a country's image and livelihood, questioning its origins becomes more than an academic exercise. It becomes a delicate act of cultural reinterpretation with real-world consequences. The promise of a single, definitive answer is a powerful lure. In an age of satellites and particle accelerators, it feels like we should be able to point a device at the Sphinx and receive a precise digital readout of its birth year. Modern science offers tantalizing tools that could, in theory, cut through the noise. Imagine a technique like cosmogenic nuclide dating. This method doesn't date when the stone was formed, but rather how long its surface has been exposed to the open sky. It works by measuring the buildup of rare isotopes in the rock, atoms created when cosmic rays from space bombard the stone over millennia. In a perfect world, a clean sample from an untouched part of the Sphinx enclosure could tell us, with scientific precision, exactly how long that surface has been weathering under the Egyptian sun. Another approach lies in microscopic analysis, studying the ultra-thin weathering rind on the limestone at a cellular level to distinguish between the chemical signatures of rainfall versus salt crystallization. These are not science fiction, they are real, sophisticated methods used to date everything from glacial retreats to ancient landslides. Their potential application to the Sphinx represents the dream of moving beyond interpretation and into the realm of measurable, repeatable fact. For a moment, it seems the debate could finally be settled by a laboratory report. Yet the Sphinx, true to its enigmatic nature, guards its secrets well. The path to that clean, definitive sample is blocked by a series of very real and stubborn obstacles. The most profound is the monument's long history of restoration. Those layers of ancient and modern mortar, those replaced stones, they don't just alter the appearance, they contaminate the very chemistry a scientist needs to analyze. A cosmogenic nuclide test on a block repaired in Roman times would only tell us how long that repair has been exposed, not the original core stone. To get a pure reading, researchers would need access to the primordial limestone, deep beneath the surface patina and untouched by human hands for its entire history. Finding such a spot is nearly impossible, and verifying its purity is a challenge in itself. Then comes the even greater hurdle, the ethics and practicality of invasive sampling. Taking a core sample from the Great Sphinx of Giza is not like drilling into a remote cliff face. This is a protected World Heritage icon, a symbol of national identity. The idea of removing even a small piece of it for destructive analysis is something cultural heritage authorities are understandably and almost certainly going to refuse. The quest for a single, irrefutable test continues, but we are forced to confront a humbling possibility. The Sphinx, by its very nature as a living, restored, and endlessly complex monument, may be uniquely designed to resist a simple scientific verdict. Its truth is not a number waiting in a database, but a story woven from geology, archaeology, climate data, and human history. A story where the final chapter may always be written in pencil, open to the next generation's interpretation. Regardless of the final verdict, the legacy of this debate is inseparable from the two men who gave it a voice. John Anthony West was not a trained Egyptologist, but a scholar of symbolism and ancient wisdom traditions. He approached the Sphinx not with a trowel, but with an artist's eye and a rebel's instinct. His great contribution was not a discovery of new evidence, but a radical re-seeing of evidence that had been in plain sight for centuries. He dared to ask a question that the established field had never seriously considered, forcing the world to look at a familiar icon and see a geological document. To turn that provocative question into a credible scientific challenge, he sought out a partner from a world far removed from his own. Dr. Robert Schoch, a geologist with the solid credentials of Boston University, brought the rigorous language of his discipline to the sands of Giza. His analysis provided the foundational argument that transformed speculation into a serious hypothesis. This partnership was itself a kind of monument, built from the meeting of two very different minds. West provided the intuitive leap, the big-picture vision that asked what if. Schoch provided the meticulous, empirical framework to test that vision against the hard reality of the stone. Their collaboration stands as a powerful example of how genuine paradigm shifts often begin, not within the cozy confines of a single academic field, but in the sometimes awkward, always fertile intersection between disciplines. It is in these borderlands where archaeology meets geology, where history meets climatology, that old assumptions can be challenged most effectively. For his part, Dr. Schoch paid a professional price by lending his scientific authority to a question deemed heretical by many Egyptologists. He faced significant criticism and skepticism from peers. This is a common story in the history of science, where those who challenge a consensus often bear the initial brunt of institutional resistance. Whether one believes their water erosion hypothesis is correct, partially correct, or entirely mistaken, their impact is undeniable. They fundamentally enriched the conversation around the Sphinx. They insisted that geology must have a seat at the archaeological table, that the story of a monument is written not only in the artifacts around it, but in the very fabric of its stone. By demanding we ask what if, they opened a door to a deeper, more complex, and far more intriguing mystery, ensuring that the Great Sphinx would be seen not just as a solved artifact of the past, but as an active question for the future. The true weight of this debate lies not in the data alone, but in how we process it. At its heart, the struggle over the Sphinx's age is a living example of how science and history actually work, a process far messier and more human than we often admit. It mirrors a powerful idea from the philosopher of science Thomas Kuhn, who described knowledge not as a steady march toward truth, but as a series of long, stable periods he called paradigms. An established paradigm is like a well-worn map. It guides research, frames questions, and tells a coherent story. The traditional timeline of ancient Egypt is a supremely successful paradigm. For over a century, it has helped archaeologists make sense of tombs, temples, and artifacts, fitting them into a logical, progressive sequence. It is a productive framework that has yielded incredible discoveries. The water erosion hypothesis, however, acts as a profound anomaly. It is a piece of evidence that does not fit neatly onto the existing map. According to Kuhn's model, when a significant anomaly emerges, the initial reaction of the scientific community is not usually to celebrate a breakthrough, but to protect the established paradigm. The anomaly is often dismissed, explained away, or set aside as a puzzle for another day. This is not necessarily a sign of stubbornness or closed-mindedness, but a natural defense of a system that has proven useful and reliable. We see this pattern vividly in the Sphinx debate, from the early dismissals to the more recent, cautious considerations. The journey of this idea from fringe theory to a subject of serious academic discourse follows the historical script of how revolutionary concepts are slowly assimilated. This process forces a deeper, almost unsettling question upon us. How do we truly know what we know about the past? Is our history a collection of settled, immutable facts, or is it a best-fit model, a story we have constructed from the available evidence, a story that must remain open to revision when new pieces of the puzzle are found? The Sphinx, in its silent majesty, challenges more than a carbon date or a king list. It challenges our very confidence in the narrative we have built. It asks us to hold our understanding of the ancient world a little more lightly, to acknowledge that the past is not a closed book but a manuscript where some pages may have been stuck together for centuries, waiting for the right question to gently separate them and reveal a text we never expected to read. If the stone was first shaped in that distant, rain-swept past, its purpose may have been utterly different. A lion carved not by a pharaoh but by a forgotten culture would not be a symbol of royal power in the dynastic sense. Its meaning shifts from a political statement to a cosmic one. Researchers looking through this lens propose a breathtaking reinterpretation. They suggest the Sphinx was not originally a portrait of a king, but a monumental representation of the constellation Leo. This idea ties into the grand cycle of the heavens known as the precession of the equinoxes, where the backdrop of stars at the spring equinox slowly shifts over a 26,000-year cycle. Around 10,500 years before the Common Era, the sun on the spring equinox rose against the stars of the constellation Leo. Could the Sphinx, gazing precisely eastward, have been built as a terrestrial marker for that celestial moment, a stone lion forever aligned with the lion in the sky? This theory of a Sphinx age proposes the monument is a time capsule from an epoch when humanity, we are told, was barely emerging from the last ice age. It weaves the statue into a narrative of profound astronomical knowledge possessed by a lost civilization, a culture that understood the slow wobble of our planet and built a guardian to commemorate an age. Such concepts, championed by authors like Graham Hancock, extend far beyond Giza. They connect the Sphinx to other enigmatic sites worldwide, from Göbekli Tepe to the Andes, suggesting a global network of forgotten wisdom that collapsed at the end of the last ice age. For mainstream archaeology, this is a bridge too far. Scholars argue there is no archaeological evidence whatsoever for such a sophisticated global culture in that era, and they view the astrological alignment as a coincidence retrofitted to a predetermined idea. They see it as compelling myth-making, not science, yet the power of this vision is undeniable. It resonates because it answers a deep, almost spiritual hunger. The Sphinx becomes more than a historical artifact. It transforms into a symbol of humanity's lost connection to the cosmos, a silent teacher from a golden age. This shows how the monument acts as a vast stone screen. We cannot help but project our own deepest questions onto its weathered face. Is human history a simple, linear progression, or is it a story of cycles, of rises and falls, of knowledge gained and catastrophically lost? The debate over water erosion, at its most profound level, is really a debate about which of these stories we are willing to believe. The story of the Sphinx did not remain locked in academic journals. It found a megaphone in popular culture, transforming a scholarly debate into a global mystery. A pivotal moment came with the 1993 television documentary The Mystery of the Sphinx, narrated by Charlton Heston. This program brought the compelling visuals of the erosion patterns and the charismatic arguments of John Anthony West and Robert Schoch directly into living rooms across America and beyond. For millions of viewers, this was their first, and often only, exposure to the idea that the Sphinx might be thousands of years older than believed. The documentary's strength was its storytelling, framing the investigation as a thrilling detective story with high stakes, the potential rewriting of human history. Yet, in its dramatic presentation, complex geological nuances were often streamlined for clarity and impact. The narrative leaned heavily into the classic underdog archetype, positioning West and Schoch as brave truth-seekers challenging a rigid and defensive academic establishment. This framing, while powerful and engaging, risked simplifying a multifaceted scientific disagreement into a binary battle of heroes versus villains, of suppressed truth versus official dogma. The media's love for a clear conflict amplified this polarization. Subsequent books, magazine features, and countless internet forums further fueled the public's imagination. Online, the debate found a second life, with passionate communities dissecting every new photograph, every geological paper, and every alternative theory. This created a powerful base of public support for the older timeline, a testament to the story's deep resonance. People were not just interested in the geology, they were captivated by the idea of a lost chapter, a forgotten civilization that conventional history had overlooked. This popular embrace gave the hypothesis a cultural weight far beyond its academic standing. However, the media's focus on controversy and cover-up sometimes came at the cost of nuance. The legitimate, scientifically grounded counterarguments from mainstream Egyptologists and geologists were often presented as dismissive or defensive, rather than as part of a necessary, rigorous dialogue. The public, enthralled by the mystery, was sometimes left with a distorted view of how historical and scientific research actually functions, a process built on skepticism, peer review, and incremental evidence rather than dramatic revelations and conspiracies. The journey of the Sphinx Water Erosion Hypothesis from a geological observation to a pop culture phenomenon reveals a crucial truth about how we come to understand our past. It shows that media does not merely report on science, it actively shapes the narrative, choosing which questions to amplify and how to frame the conflict. In doing so, it can democratize knowledge, inviting everyone to ponder a profound mystery. But it can also, inadvertently, turn a complex conversation that requires patience and subtlety into a spectacle of absolutes, where the gray, uncertain, and wonderfully complicated nature of the truth becomes harder to see. Perhaps the most promising path out of this stalemate is not a battle to the end, but a careful weaving together of truths from both sides. What if the story of the Sphinx is not one of a single creator, but of multiple chapters written across vast stretches of time? This emerging idea is known as the two-stage or multi-phase model, and it offers a compelling middle ground that attempts to synthesize geology with archaeology. The proposal is elegant in its simplicity. First, picture the Giza Plateau thousands of years before the pyramids, during one of those wet climatic periods. A prominent limestone outcrop, what geologists call a yardang, rises from the landscape. Over centuries, the heavy rains of that green Sahara beat upon this natural formation, sculpting its base into those deep, vertical fissures and rounded hollows that so intrigue researchers today. This was not a carved lion, but a naturally weathered rock formation, bearing the unmistakable signature of water. Then, fast forward to the age of the pharaohs. The Old Kingdom engineers, masters of stone and vision, arrive at the plateau. They look upon this ancient, eroded monolith and see something remarkable. Its weathered form already suggests the powerful shoulders and reclining shape of a lion. They recognize an opportunity, a gift from the land itself. With incredible skill, they set to work. They quarry around it, defining the enclosure. They take tools to that water-softened stone, refining the natural form, carving the details of the paws, the tail, and most crucially, reshaping the top into the regal human head of a pharaoh. In this narrative, the Sphinx is both ancient and young. Its body carries the geological memory of a lost, rainy world, while its final form and ceremonial purpose are undeniably the achievement of 4th Dynasty Egypt. This synthesis does not force us to choose between water erosion and pharaonic builders. Instead, it proposes a collaboration across millennia, where human genius recognized and completed a work that nature had already begun. It is a story of convergence where deep time and human history meet at the feet of a single, magnificent guardian. This perspective gains profound resonance when we step back from the sands of Giza and look at a wider map. The Sphinx is not an isolated anomaly in the story of human achievement. Across the globe, other ancient stones are whispering similar challenges to our historical timelines, creating a chorus of questions that can no longer be ignored. In southeastern Turkey, the discovery of Göbekli Tepe sent shockwaves through archaeology. This sprawling complex of massive, intricately carved stone pillars arranged in circles has been firmly dated to around 9,600 years before the Common Era. That is over 6,000 years before Stonehenge and 5,000 years before the first cities of Mesopotamia. Its builders, according to the evidence, were not settled farmers or subjects of a king, but communities of hunter-gatherers. This single site shatters a long-held assumption that monumentality requires agriculture, cities, and complex hierarchy. It proves that the human impulse to reshape the landscape on a grand scale, to coordinate labor for spiritual or communal purpose, existed far earlier and in very different social structures than we ever imagined. While Göbekli Tepe is not a carved lion, its existence is a monumental proof of concept. It demonstrates that the cultural and organizational capacity for large-scale stonework was present in the very time frame that geologists propose for the Sphinx's initial carving. It shows us a world where ancient peoples were not merely surviving, but conceiving and executing projects that would stagger us today. This parallel does not prove the water erosion hypothesis, but it fundamentally changes the intellectual landscape. It makes the idea of an older Sphinx seem radically less implausible. Suddenly, we are not asking if a pre-pharaonic culture could have built such a thing, because Göbekli Tepe stands as irrefutable evidence that such cultures elsewhere absolutely could. The question shifts from was it possible to did it happen here? From the Andes, where sites like Puma Punku display stone-cutting precision that baffles modern engineers, to submerged structures off various coasts that hint at landscapes lost to rising seas, a pattern emerges. Our ancestors were far more sophisticated, mobile, and interconnected than the textbook timeline suggests. These global parallels weave a new backdrop for the Sphinx debate. They suggest that the dawn of civilization was not a single bright light in one river valley, but a slow, spreading sunrise with many early peaks, some of which faded long before others became the empires we remember. In this light, the Great Sphinx stops being a lonely outlier and becomes a potential part of a much larger and far more mysterious human story. Yet the Sphinx offers no easy answers, only a profound and enduring silence. This very silence is the source of its timeless power. It stands not as a declaration, but as a question carved in limestone, a riddle that refuses to be solved. Our fierce debate over rainfall and salt crystals, over pharaohs and forgotten epochs, reveals something far more about us than about the statue. It taps into a deep, almost primal human drive, the need to uncover our lost origins and solve the great puzzles left behind by those who came before. We are a species of storytellers, and the Sphinx presents a blank page upon which we feel compelled to write a narrative, to fill that silence with meaning. This mystery thrives in the fertile tension between two ways of knowing. On one side stands the immense, carefully built edifice of established knowledge, the product of generations of scholarship and meticulous excavation. It represents order, context, and the weight of consensus. On the other side stands the spark of daring speculation, the rebel thinker who looks at the same evidence and asks a different question. This is the classic, compelling drama of the outsider challenging the institution, a narrative that resonates because it speaks to our innate skepticism of authority and our hope that truth can be revolutionary. The Sphinx debate is a perfect stage for this eternal conflict, making the geological details feel like part of a much larger human story about who gets to tell our history. Ultimately, it may not matter which timeline you personally find more convincing. The monument's true gift is its ability to compel us to look deeper. It forces us to question the narratives we've been handed, to examine the evidence with fresh eyes, and to acknowledge the staggering gaps in our understanding of the human journey. Whether you see a 4,500-year-old masterpiece of a known civilization or a 10,000-year-old relic of a forgotten world, you are participating in the same act of marvel. You are standing in awe of the endurance of human creation, of the audacity to shape a mountain into a guardian meant to outlast empires, climates, and millennia. And so, the guardian remains. Its eroded face, whether recarved or original, continues its eternal gaze toward the dawn. It does not guard a pharaoh's tomb or a hidden hall of records. It guards something far more valuable, its secret, and in doing so, it issues a silent challenge to every generation that passes before it, a challenge to seek, to question, and to never stop wondering about the true depth of our own story. The search for an answer, it seems, is the answer itself, a journey that keeps our curiosity alive and our sense of wonder pointed like the Sphinx steadfastly toward the horizon. The stone has spoken, but it speaks in a language of beautiful uncertainty. Our journey through the Sphinx Water Erosion Hypothesis reveals a landscape far more complex than simple right or wrong. We have navigated a terrain where compelling geological arguments for great antiquity stand face to face with robust archaeological context and equally plausible models of desert weathering. This is not a story with a villain and a hero, but a profound dialogue between different ways of seeing the same ancient stone. We have met the pioneers who dared to challenge a long-held orthodoxy, and we have listened to the scholars who defend a timeline built from generations of meticulous work. Their conflict is more than an academic quarrel. It is a living testament to the evolving nature of history itself. It reminds us that our past is not a closed book gathering dust on a shelf, but a story being continuously rewritten, its pages illuminated by each new piece of evidence, every fresh perspective, and every daring question. This process of reinterpretation is not a sign of weakness in our knowledge, but its greatest strength. It means our understanding is alive, capable of growing and changing as we learn more. Whether you are convinced the Sphinx bears the scars of a forgotten rainy epoch, or you believe it is a masterpiece of the old kingdom shaped by the desert's own patient chemistry, the discussion itself has enriched our collective understanding. It has sparked a global curiosity, inviting millions to look at a familiar icon and see not just a statue but a mystery. It has taught us to read stone as a historical document, to consider climate as a character in the story, and to appreciate the incredible depth of time in which human ambition operates. So, as we leave the sands of Giza and the silent gaze of that guardian, we are left with the most personal question of all. What do you believe lies behind the Sphinx's inscrutable smile? Does it guard the secrets of a lost world, or is it the ultimate symbol of a pharaoh's eternal power? The evidence is before you, the arguments have been made. The choice of which story resonates is now yours. We would love to hear your thoughts in the comments below. What timeline feels right to you and why? If you enjoyed this deep dive into history's greatest mysteries, subscribe and join us as we continue questioning the stories written in stone.